Good morning, my dear followers. This is video number 405, which is based on a simple linear regression model in STATA. And I am doing this for the beginners. This is not advanced level. So this presentation or this video lecture is meant for the beginners. I'll be using example data set from STATA, and the file name is NLSW88DTA. This is National Longitudinal Survey data, and that can be downloaded from example data set installed with STATA. And here I will download this one, NLSW88.DTA. And in this file I have two variables that will be used for this analysis. One is wage, hourly wage, that is my dependent variable, and job tenure in years, that is independent variable. First of all, I would like to draw a scatter diagram of the two variables. This is the dependent variable, that is the hourly wage, and this is the job tenure, that is the independent variable, and here is the scatter diagram of the two variables. So this gives us a guess how the two variables move together. So we can guess that there is a linear relationship between the two variables, but we will check this later on. This is the regression output that will be done, and I'll explain this after performing the simple regression analysis in STATA. And finally, I will fit the regression line to the scatter diagram of the hourly wage and job tenure. So how to do all that, I'll show it just now, and for that purpose I'll open my STATA. So initially when I open STATA, it will be like this. As I mentioned that I will download data from the file menu, and this is example data set, and in this I am using this data set. So so here is my data. Now let us have a quick look of this data. Let me bring it here so that you can see. So this is the data, and if you scroll down, the total number of observations in this file are 2246, and there are a large number of variables in this, starting from age, race, married, never married, and so on. And here are our variable of interest. So I'll be using this variable wage, that is hourly wage rate, and finally I will use tenure as an independent variable. So let me minimize this, and let me first of all make the graph of the two variables. So I'm using scatter diagram, and I'll create. So my y variable is wage. I'll put it here, and my x variable is tenure, and I'll sort on x. Let me check the properties. So the color should be blue. Let me use this color, and size, this should be medium. Now after this I'll accept, and I'll show the diagram. So this is the scatter diagram of the hourly wage and job tenure, and it exhibits more or less linear relationship. So if we fit a linear regression to this model, then the straight line may pass through these points. So I'll also show you that. After that, let me run the regression, and for regression, linear regression, and my dependent variable is wage. My independent variable is tenure. Pressing OK, and again here are the results of my regression. So the command is regress. This is the dependent variable and tenure is the independent variable. So I have a number of information here. The total number of observations for this is 2231. There are some missing observations, and this is the F stat, that is 72.66. its p value is 0.00. So this is highly significant. R squared value is 0.03. adjusted R square is 0.03. This is just a hypothetical example, and this is root mean square error. This is the analysis of variance. This is model sum of square. This is residual sum of square or unexplained sum of square. This is total sum of square, and these are degrees of freedom. And this is the independent variable tenure. This is its coefficient. This is its standard error. This is its, if I divide this by this, we get this t, and this is its p value, and this is 95% confidence interval, and this is the intercept of this model. Now I would like to predict residual from this model. Predict of the dependent variable. So I may name it as wage resid. So this variable has now been generated or created, and it's here. Before it was not here, but I just created it, so it has been added to the variable list. Now I would like to fit the regression line to the graph that I made earlier. So let me go again to this, and this is plot 1 that I just showed a while ago. Now I will create another, and this time I want to fit a regression line to the scatter. So this time my y variable should be the residuals, and my x variable is tenure, and we should sort this on that. So let me check the line properties. The color should be red. Let me see where it is. Yes, here it is red, and I can also make it thick. So I'll accept this, and after this, here is my regression line that I fitted to the scatter diagram. So these blue dots, these shows hourly wage rates, and along this x-axis we measure job tenure, and this red line is the fitted line. So this is the simple linear regression model. How can we fit? And this is the best fit for this data. Let me also explain these results a little more. So let me go to the regression. First, this is the scatter that I showed earlier. This is the scatter diagram of job tenure and hourly wage, but there is no fit in this. So the pattern is more or less that there is a positive relationship between job tenure and hourly wage. After this, this is the regression that I just showed a while ago. I copied it from there. So this is ANOVA, as I mentioned. Total number of observation, as I mentioned, 2231. F stat value is 72.66. This is its p value. This is 0.00, so highly significant. The R squared value is 0.03, which is very low, and the adjusted R square value is 0.0311. The root mean square error is 5.6741, and here is my independent variable. Its coefficient is 0.1858. Its standard error is 0.02. So if I divide this coefficient by this value, I get this value, and its t is 8.52, which is significant. Here is the p value of the t state, and this is a 95% confidence interval, and this is the intercept or constant for this model. So it means if the tenure is 0, then still excuse me, the hourly wage will be 6.68. This is its standard error, this is its t value, this is its p value, and this is the 95% confidence interval. Finally, I will show the actual scatter of the data of the hourly wage and its fitted line. So it's here in this diagram. This is the scatter, the actual scatter. These are the observed values of hourly wage against job tenure, and this blue straight line shows the regression line, and this is the fitted. This shows the fitted values of the hourly wage. So it means as a job tenure increases, hourly wage increases at this slope. So the slope of this line is the coefficient of job tenure in the regression line, which I showed you in the earlier, and this is the coefficient, and this is the slope of this line, the slope of this line, this fitted line. I hope this was quite easy, and you may easily understand this. If you have any problem, you may ask me a question in the comments, and I'll show. But I have also given you the link for the dataset, and the dataset is available in the STATA file menu, example dataset, and the file name is nlsw88.dta. If you haven't yet subscribed to the channel, kindly subscribe to the channel and click on the bell icon. You will get notification about my other videos that I will upload for you. I thank you very much for watching this video. Kindly share this channel and this video with your friends, with your colleagues, and with your students, so that they may also get benefit from this presentation. Thank you, and see you in another video.